Hi, this is Mick Elliott, editor at Electronic Specifier. I'm on the Analog Devices stand with Enda Nicholl, the marketing manager for magnetic sensors. And we have some exciting news to bring you because we have the first ever multi-turn position sensor. Enda, first of all, how is this different from anything on the market right now?
Yeah, so on the market today there's a variety of different angle sensors, magnetic based. You have GMR, TMR and Hall effect, but they all have one limitation, and that's that they can only measure a full range of 0 to 360 degrees or one single turn. So this is the first ever multi-turn absolute true power on position sensor. It has a range of 46 turns, so you can go from 0 to 46 turns, and it's true power on. So if you lose your position, lose your power, and lose your position, and there's movement when the power is down, this sensor will track that motion without any backup batteries or anything else, and then when you power back up, you can read the new position information.
Okay. And so you've got a sort of almost like a legacy there, a backup if anything goes wrong.
Well, it doesn't need a backup because it works on a principle of GMR. It's a GMR process and a phenomenon known as shape anisotropy. So as you rotate a magnet in front of our sensor, a GMR spiral, domain walls move through the spiral, and they change the resistance value of the spiral legs permanently without any power. The magnet effectively is the power. So when you power the sensor back up after the magnet moves, we tap into the corners of the spiral, and we can read back the change or the number of rotations the magnet made when the power was down. So we can read on power on the new true power on position information.
Okay. I mean, what was the genesis of this product? Where was it developed, and where did the idea come from?
Yeah, there's the IP has been there for some time. The company Novatechnik have it on the market for a short while, but the problem was trying to industrialize it into a large volume scale for industrial and automotive volumes, and that's where ADI kicked in, and we brought that technology into our fabrication facility in Limerick in Ireland, and we've scaled that up. We have also the ASIC obviously is our standard bread and butter business anyway, so combining the ASIC with the sensor, the GMR spiral sensor, and we also have an AMR angle sensor in the chip as well, and that gives you the precision angle information. So we combine an AMR angle sensor with the GMR spiral and the ASIC to give you the 0 to 16,500 degrees position information.
Okay, that's great. Maybe we can turn and get some examples if that's...
Yeah, exactly. I'd like to show you this. This is a fairly basic demonstrator here. So you can see that as I rotate this shaft, that we're recording the turn information, the angle information, and from that I'm inferring the absolute linear position of this block as it moves over and back. Now if I remove the power at say 16.25 degrees completely, and I do 4 rotations, say 1, 2, 3, 4, or let's say 5 rotations, power it back up, it's gone from 16 to 21, so it's exactly 5 turns. So that shows you that the sensor has recorded and keeps tracking the position information even when the power is down. And there are multiple applications for this. So, for example, in the industrial space, there's rotary to linear actuators, where you would need a linear transducer. This sensor will allow you to eliminate that linear transducer completely. Here we have an example of a wire draw encoder. So again, it's very similar. The wire draw here, as we draw the wire from the encoder, we count the number of turns and the angle information, and we can infer the actual extension of the cord from the wire draw encoder. Another example is this seatbelt system here, which I'll show you.
Okay, now this multi-turn position sensor has applications in the automotive market. So, Enda, can you just talk us through this?
Yeah, we have two demonstrators here. The first one is a seatbelt retractor, motorized seatbelt retractor system. The multi-turn sensor is here opposite the spool of the retractor. So, as you can see on the display, as we change the belt extension, we're counting the turns, we're measuring the angle, and we're providing the extension of the belt, as you can see there. So if Jordan removes the belt, you'll see that it goes back from 7 turns back to 2 turns. And if I remove the power from the sensor, and now Jordan puts back on the sensor, there's no power going to it. And if I repower it back up here,
Okay.
yeah, you can see that it's now at 8 turns, so it has recorded the belt extension and buckling without any power in the car. So why is that important? Right, so for example, for airbag deployment systems, it's important to know the classification of the occupant, how large, how small they are, but also how far they are forward in the seat. Jordan, if you move forward in the seat, or towards the airbag, you can see that the belt is extending. So that information then is provided to the airbag ECU, and then the airbag will deploy at a different rate depending on how close the occupant is to the airbag. So it adds occupant classification information to seatbelt retractors, which is a new functionality.
Okay. And that's a big safety feature for...
Absolutely, yeah. And there's one other demonstrator here. It's steer-by-wire. So here we have the multi-turn sensor positioned at the end of the motor shaft, opposite a dipole magnet rotating multiple times. This is a typical steer-by-wire system where the steering wheel is separate, is not mechanically linked to the wheelbase.
Yeah.
So here if we, I'm just going to have to power this up 1 second. Yellow one. Okay, so if Jordan moves the steering wheel, you can see that this wheelbase is tracking that wheel movement. And you can see our multi-turn sensor here is tracking the wheel angle all the time. So if we take your hands off the steering wheel, if you just press the black button, Jordan. Now at 31.75, I've removed all the power from the system, and for example, we move the wheels like that. Now if we power it back up by pressing the green button, yeah, it should go back to 31.75 turns, as you can see there.
Yep.
So it has tracked all that motion without any power being applied to the system, which is critical for steer-by-wire systems, because in autonomous vehicles, for example, in the future, when you power the car up, it needs to know exactly the exact angle of the wheels. Otherwise, the car will take off in the wrong direction. It'll be a disaster. So, it tracks that information when the power is down. The other way you could do that is add a gearbox here, or add a linear transducer, or continuously power this sensor at all times, which is undesirable. So it simplifies mechanical designs. And so it's very applicable in this application going forward.
Okay, that's terrific. And just as a quick question, I believe this product is sampling at the moment, is that correct?
It's sampling at the moment. It's going to release in October of this year, but we have final silicon samples available for customers if they want to contact analog.com.
Okay, Enda Nicholl from Analog Devices, thank you very much.
Thank you.